Start inside a supply chain blind spot. The moment a missile becomes dependent on something mined, refined, and processed thousands of kilometers away in quiet industrial zones. Build a cause and effect chain where raw minerals move through refining choke points and gradually become defense-grade components. The real leverage isn't China owning minerals, but controlling the chemical processing stage where raw earth becomes militarily usable material. Mood applied, cold and methodical. There's a specific kind of vulnerability that doesn't show up on military balance sheets. It doesn't sit in troop numbers. It doesn't appear in budget hearings in Washington. And it definitely doesn't show up in the way most people imagine geopolitical power: flags, ships, or bases. It sits in something far more unglamorous: the refining stage between raw mineral and usable component. A missile guidance system doesn't care where cobalt is mined. It cares who turns that cobalt into a high-purity alloy that can survive heat, vibration, and electromagnetic noise. That gap between rock and readiness is where the leverage actually forms. And over the last 2 decades, that gap has been increasingly shaped by one country. China doesn't just mine a large share of the world's rare earths. That part is well known and slightly misleading when taken alone. The deeper position is in processing capacity: separation, purification, metallurgical refinement. The industrial steps that turn mixed ore into usable inputs for magnets, semiconductors, and hardened alloys. That distinction sounds technical, almost boring. It isn't, because modern defense systems don't run on raw materials. They run on processed certainty, materials that meet exact tolerances, batch after batch, under conditions that most suppliers outside Asia simply stopped investing in years ago. If you trace the supply chain of something like a precision-guided missile, you don't find a single point of dependency. You find layers: rare earth magnets in actuators, gallium compounds in radar systems, germanium in infrared optics, graphite in thermal shielding. Each of these has its own sourcing map, its own subcontractors, its own last mile before it becomes part of a weapons platform. And in a surprising number of those maps, the processing step routes through Chinese industrial capacity. The United States Geological Survey has repeatedly flagged this in its mineral commodity reports, not as a headline, but buried in tables showing global refining concentration. The Pentagon has run parallel assessments under its critical minerals strategy, trying to identify where domestic production could realistically reemerge. The pattern is consistent. Mining can be diversified faster than refining. That difference matters more than it should, because mining is geography. Refining is infrastructure, chemistry, and scale takes decades to rebuild once it leaves. There's a common counter-argument here, that countries like the US or Australia can simply reshore or friendshore these supply chains. On paper, that's true. In practice, the bottleneck isn't political will. It's the absence of midstream industrial ecosystems: the specialized plants, the trained chemists, the waste handling systems, and the price structures that make low-margin processing viable. China didn't stumble into this position. It consolidated it through long cycles of industrial policy, environmental tolerance for heavy processing industries that others phased out, and aggressive vertical integration from mine to export. Now here's where the uncomfortable layer appears. Even defense contractors in the US, companies building systems explicitly designed for strategic independence, often buy components that originate in these extended supply chains. Not because of negligence, but because alternatives are either too expensive, too inconsistent, or simply not available at required scale. At that point, dependency stops being theoretical. It becomes contractual. And once it becomes contractual, it becomes slow to unwind. There's a tendency in Washington policy circles to treat this as a solvable procurement problem. Replace supplier A with supplier B, issue guidelines, build incentives. But that framing assumes a level of redundancy that doesn't fully exist in high-purity material processing, which raises a more uncomfortable question than most reports are willing to sit with. If the system depends on a small cluster of processing hubs, and those hubs are geographically concentrated, is this still a supply chain or something closer to a structural constraint? I don't think there's a simple answer yet. The data points in one direction, but the system is too interconnected to reduce cleanly. And this is where the next layer starts to matter. What happens when those processing choke points are no longer just economic infrastructure, but political instruments that can tighten or loosen depending on external pressure? Because that possibility changes how you interpret every procurement delay, every export restriction, and every strategic partnership announcement tied to critical minerals. The question isn't whether the minerals exist, it's who can reliably turn them into something a missile can actually use. If you want to understand how this dependency actually behaves in the real world, you have to leave the theory behind and look at moments where the system was tested. One of the clearest stress points came in 2010 between China and Japan over rare earth exports. It didn't start as a mineral story. It started as a political dispute, but the mechanism it exposed was industrial. Japan had assumed, like many advanced economies, that global trade meant replaceable suppliers. China briefly tightened rare earth exports during the dispute period. The volumes weren't permanently cut off, but the timing was enough. Prices spiked. Japanese manufacturers started scrambling, not for mines, but for processed inputs used in magnets and electronics. That distinction is where the entire issue sits, because what Japan discovered wasn't a shortage of minerals, it was a shortage of refined consistency. You can find rare earth deposits in Australia, the United States, even parts of Africa. What you cannot instantly reproduce is the ecosystem that turns those ores into 99.999% pure oxides at industrial scale, with stable output and predictable cost curves. That gap is not academic. It determines whether a missile guidance system works under stress conditions or fails mid-flight. Fast forward to today, and the same structural logic shows up in less visible but more strategically important materials. Take gallium. It's used in radar systems, satellite communications, and high-frequency electronics. China controls the majority of global gallium refining capacity. In 2023, it imposed export controls on gallium and germanium. The official framing was regulatory, but the effect was immediate. Downstream industries in Europe and the United States had to reassess inventory assumptions they had never seriously questioned. What matters here isn't just the restriction, it's the reaction it forces. When a country realizes that a single export decision can ripple into defense electronics, it doesn't just look for alternatives. It starts redesigning procurement systems, increasing stockpiles, and in some cases, accepting higher costs for lower certainty. That is already a form of leverage, even if no shipment is fully cut off. Now, the counterpoint usually raised is that China is also dependent on global demand, that it cannot weaponize these flows without harming its own industrial base. That's partially true, but incomplete, because dependency is not symmetrical at every stage. China's exposure is concentrated in end markets. The West's exposure is concentrated in midstream processing. Those are not equivalent positions. One is flexible consumption. The other is infrastructural bottleneck control. And bottlenecks don't need to be activated to matter. Their existence changes behavior before any action is taken. This is where most analysis stops, but the more interesting layer is operational. Defense contractors don't interact with China as a single node. They interact with tiers of suppliers, magnet producers, alloy refiners, component manufacturers. Many of those firms operate outside China, but rely on Chinese processed inputs somewhere upstream. So even when a supply chain looks geographically diversified on paper, the chemical fingerprint of the material often traces back to a small number of processing hubs. That creates a situation where substitution is not binary. It's gradual, expensive, and uneven. You don't replace a supplier. You rebuild an entire chemical industrial chain beneath it. And that takes time measured in years, sometimes decades, because it requires more than capital. It requires regulatory alignment, environmental tolerance for processing waste, technical labor, and sustained price support while new facilities reach efficiency. Most governments underestimate that timeline because they think in election cycles. Industrial chemistry does not. There's another subtle effect that rarely gets discussed. When supply chains are concentrated, companies start optimizing for stability rather than resilience. They choose suppliers who have proven scale, even if that scale is geographically concentrated. Over time, that rational choice deepens the dependency it was meant to avoid. It's not a failure of planning. It's a consequence of efficiency logic applied over long periods. So when policymakers talk about decoupling, they are not just reversing trade flows. They are trying to unwind decades of optimization that made the system cheap, fast, and predictable. And that's where friction appears. Because the system that produces affordable electronics and advanced weapons platforms is, in part, the same system that created the dependency in the first place. The next layer is where this stops being abstract and starts becoming strategic pressure, not in the form of full cutoffs, but in the ability to selectively tighten access at specific nodes when geopolitical conditions shift. And that possibility changes how every country quietly prices risk, even when nothing official changes on paper. There's a point in every supply chain discussion where the numbers stop feeling like economics and start feeling like geography made political. Take rare earth processing again, not mining, processing. Depending on the year, China accounts for roughly 60 to 70% of global rare earth oxide production and an even higher share in separation and refining steps. The United States, for contrast, has mining capacity at places like Mountain Pass in California, but historically lacked matching midstream separation infrastructure at scale. That gap is the real story. Not who digs it up, who can refine it into something consistent enough to be engineered into a weapons system. Now, here's where it gets more uncomfortable. Because even when alternative refining projects exist, in Australia, the US, parts of Europe, they don't operate in isolation. They depend on reagents, machinery, and sometimes precursor materials that still trace back to Chinese industrial supply chains. So even diversified systems often have embedded dependencies that are invisible unless you map them layer by layer. And that's where the picture gets more fragile than most policy documents admit. A missile program doesn't just need rare earth magnets once. It needs them across multiple production cycles, across multiple subcontractors, across maintenance and replacement timelines that stretch decades. So the question isn't, do you have access today? It's, can you guarantee access consistently under stress over time? That word, consistently, is where systems break. Because industrial consistency is not just production. It's chemistry, logistics, energy pricing, environmental regulation, and labor specialization all aligned at the same time. China's advantage isn't just scale. It's the compression of all those variables into a single industrial ecosystem that has been refined over decades. Now, let's challenge this a bit. There's a strong argument, especially in US strategic circles, that this dependency is overstated. That in a crisis, supply chains will reroute, that allies will step in, that stockpiles will buffer shocks. And to a degree, that's correct for short disruptions. But long-duration strategic competition doesn't behave like a crisis. It behaves like pressure applied over time. Small frictions, incremental delays, price distortions, not a shutdown, a recalibration of cost and reliability expectations. That's harder to respond to because it doesn't trigger emergency thresholds. For example, if export licensing on a key mineral tightens slightly, not bans, just slower approvals, downstream industries don't stop. They adjust. They reorder inventories. They delay procurement. They absorb higher costs. And over time, those adjustments reshape industrial planning in subtle ways. That is the mechanism that matters more than any dramatic cutoff scenario. Now layer in defense manufacturing. Modern systems, F-35 components, missile guidance modules, radar arrays, are not built in one place. They are assembled through global subcontracting networks. Each node assumes upstream stability. When that assumption becomes uncertain, you don't immediately redesign the system. You add buffers, you overorder, you diversify where possible. But buffers have limits, and diversification has cost ceilings. At some point, governments face a trade-off that is rarely stated openly: higher defense costs for lower supply risk, or continued reliance on efficient globalized inputs with embedded vulnerabilities. Most systems quietly choose efficiency until pressure forces reconsideration. There's also a political layer that sits underneath this, and it's often missed. Industrial dependency doesn't translate cleanly into political control. China cannot simply turn off missile production in the US. That's not how it works. But what it can do, and what matters more, is influence marginal cost, timing, and uncertainty in the background. And in defense planning, uncertainty is itself a cost. If procurement timelines become less predictable, if input pricing becomes volatile, if substitution requires redesign rather than replacement, then strategic planners must assume slower adaptation cycles. That slows everything downstream, even without explicit confrontation. So when we talk about control, it's less about direct command and more about structural friction embedded into global manufacturing architecture. And the question that starts to emerge, and this is where the debate gets sharper, is whether that friction is intentional leverage or simply the byproduct of decades of globalization optimizing for cost over redundancy. I don't think that question has a clean answer yet, but the implications don't wait for clarity. Because once a system becomes dependent on a concentrated set of processing nodes, even neutral behavior from those nodes has strategic consequences. And that sets up the final layer. What happens when those nodes are not neutral at all, but embedded in a broader geopolitical strategy where industrial capacity is treated as long-term state power? At this stage, the discussion stops being about minerals in the ground. It becomes about whether industrial concentration itself has become a form of power projection, even when no one explicitly declares it that way. China's position in critical mineral processing didn't emerge overnight, and it didn't emerge in a vacuum. It was built through long-term coordination between state policy, domestic industry consolidation, and a willingness to absorb environmental and economic costs that other economies gradually pushed out of their borders. That last part is important and often underplayed. Rare earth separation is not clean work. It produces waste streams that many Western jurisdictions tightened regulations on over time. China, especially during its industrial scaling phase in the 1990s and early 2000s, tolerated and centralized much of that processing domestically. That decision created environmental trade-offs, but it also created scale advantages that became very difficult to replicate later. So when we talk about dominance in processing, it's not just about investment, it's about sequencing. Who industrialized when, under what constraints, and with what tolerance for long-term external costs? Now bring that into the present. In recent years, export controls on materials like gallium, germanium, and certain graphite products have signaled something subtle but important. These supply chains are not purely commercial anymore. They sit at the intersection of trade policy and strategic signaling. But even here, the reality is more layered than simple weaponization. China also depends on continued export revenue, global industrial demand, and stable downstream relationships. So what emerges is not absolute control, but calibrated influence. The ability to tighten or loosen pressure points without fully breaking the system. And that is arguably more powerful than outright restriction, because outright restriction forces substitution. Calibrated friction forces adaptation under uncertainty. Now, I want to be careful with interpretation here. There's a tendency in geopolitical commentary to frame this as a deliberate master plan, as if every dependency was designed for strategic leverage from the start. The evidence doesn't fully support that level of intentionality. What is more consistent with the data is something messier. Industrial policy decisions accumulating over decades, later converging into strategic advantage once global demand for advanced materials exploded. So the question isn't whether this was all planned. The question is, what happens when an industrial system built for efficiency becomes strategically concentrated in hindsight? And here is where the uncomfortable reality sits for defense planners in the United States and its allies. You cannot instantly policy your way out of chemical industrial dependency. You can fund projects, you can subsidize plants, you can sign agreements with allies. But rebuilding refining ecosystems requires time, skilled labor pipelines, environmental permitting systems, and sustained price support that survives political cycles. In other words, it requires patience at a scale that modern democracies struggle to maintain. Meanwhile, the existing system keeps operating. Missiles still need magnets. Radar systems still need semiconductors. Guidance systems still rely on materials whose processing pathways remain geographically concentrated. So what does this actually mean going forward? I think we are moving toward a world where supply chains are no longer assumed to be neutral infrastructure. They are becoming part of strategic calculus themselves. Not just where is it made, but who can influence the conditions under which it is made, refined, and certified. And that shifts defense planning in a quiet but fundamental way. Instead of just preparing for conflict scenarios, states now have to prepare for supply chain pressure scenarios that sit below the threshold of open confrontation. That's a different kind of preparedness, less visible, more technical, more persistent. I'm not fully convinced we've collectively understood how deep that shift goes. The public conversation still treats supply chains as logistics. Increasingly, they behave like strategic terrain, and terrain can constrain movement without ever firing a shot. So the final question isn't whether China controls the minerals inside American missiles in a direct sense. It's whether the global industrial system has evolved in such a way that control is no longer about possession, but about position inside the flow. And if that's true, then the real competition isn't just over resources. It's over redesigning the map of how those resources become power in the first place. One last thought I keep coming back to. If both sides already know this structure exists, the more important moves might not be the visible ones. They might be the slow, expensive, almost boring efforts to rebuild chemistry, labor, and processing capacity outside the current centers of gravity. That takes time, more time than most political systems are comfortable admitting. If you want a CTA here, I'd just say, if this is the kind of structural analysis you want more of, stay around. There's a lot more beneath the surface of trade that we still haven't mapped properly.